The last step is the finding that compression. So it is related to point one, and so you have choices that you can make. You can do 1 2 2, 1 2 3. Since we found that everything about 2.2, I'm gonna do it for from 1 to 2. Okay, and this is the solution for that. So if you're choosing two different points, you have to start with the new conservation of energy equation. So write them down, okay? And then again, you need to have your free body diagram as well for the work term in the conservation of energy. Kind of simplify things. Delta K is gonna stay there because in point two we have the velocity. Delta I is 0. No heat or no temperature or pressure changes. Sometimes I say it this way, sometimes I say delta T and delta P are 0, and those are temperature and pressure again. Between point 1 and 2, is there a change in elevation? Yes, there is, so we keep delta UG. And do we have spring? Yes, we do, we keep that as well. And heat is also 0 because again, there is no heat. But what about the work done? To investigate that clearly, we draw the free body diagram. When we compress it, the spring force is gonna be towards the relaxed position. Okay, so this is somewhere in between 1 and 2. So point 1 is here, point 2 is there. I usually find a point somewhere in between to figure out my forces. And then since the relaxed position is again 2, then your spring force points that way. There's weight force and the normal force because it is touching the launcher. The ball is touching the launcher at that point, right? So there will be normal force. So those are the forces. And again, displacement is from 1 to 2, it's going to go that way. So normal force is going to be perpendicular. There is no work done by normal force. So I'm going to write the equation. Let me just show it. I think I'm going to show it here. There are three forces. The work done by the spring force, work done by the weight force, work done by the normal force. So hopefully we understand that normal force is already 0 because the angle is between N and D is 0. Okay, so this is theta is not 0, 90 degrees. Theta is 90 degrees, that's why. Okay. And the weight force, again, we already kept delta UG. This is also going to go away because we kept it as delta UG. Okay, don't double count that. This is important. What about work done by the spring force? Is it doing work? Yes, D and Fs points the same direction, but we're going to also eliminate that here because it is kept as delta U E. Okay, so explain the reasons, that way you can understand better. So that means the weight term is going to go to 0 as well, and that is the reason we have simplify this equation in this form. Okay, only those three things left. Now we're expanding it, and change means again 1 was initial, it's going from 1 to 2, initial to final. So it has to be 2 minus 1 for the change. So it's K2 minus K1, for example, and it goes so forth. Be careful with the signs. Change is final minus initial, right? It introduces a negative sign on the initial quantities. Now simplify one more time. Again, initially the velocity is 0. So I usually write down V1 is 0. That's why I'm neglecting that. For the gravitational potential, we said that point 2 has 0y. So I'm going to say y2 is 0. That's why it goes to 0. And UG2 is that, and UE, which is the elastic potential, at point 2 it is relaxed position, so this is going to be 0 because x2 is 0, it's relaxed. Okay, I'm gonna want to write that. Okay, so that's why it's going to be 0 as well. Now it simplifies even better. So it's in this form. Let's plug in what they are. What is K, what is UG, what is UE, and this is what you're getting with the signs carried as well. And now you're going to kind of examine what you have, how many unknowns you have. Once again, as before, we said that V2, the velocity at V2 is the muzzle velocity. So we are going to replace that with VM so we don't think that it's something different. Again, these are X1 and Y1. So X1 is what we want to get, and but there's also Y1. So what is that? So we gotta find a relation between X and Y, and once again we are going to make use of geometry. So this is if you look at the triangle here, X1 is the hypo, angle 35 is given, and on the opposite side the elevation is from Y1 to Y2. Okay, so this is 0.1, this is 0.2, and this is the elevation change. So there is a relation between X and Y. And from this, first of all, since we said the top part is positive, that's the challenge because initial height is negative. Okay, so be careful with that negative sign. And the relation between them, again, this height here, if you just find this distance in terms of x1, you would write it as x sine 35, right? But y1 is negative, so we are putting what y1 is, which is negative x1 sine 35. So x sine 35 is the magnitude of the height. But again, because that y is a position, it can take a negative sign, so we are adding that negative sign here. And there's another negative here, so it will make it positive overall. On the last term stays the same, 1/2 kx1 squared, that's what we're trying to find. But this way, we made those two unknowns as one. Okay, we eliminated the unknown. So if you rearrange your equation, what you see is a quadratic equation because it is some constant. Let me just make this bigger so I can show you clearly. The coefficient of x1 squared, the coefficient of x1, and some constants. This is like your A, B, and C. Just like you did with the time equations in constant acceleration problems. Now you can do the same thing. You can solve for x. You will get two values, and here is the answer. So it is less than half a feet. It's about 4.42 inches, and that is how much we needed to compress, okay, to verify the other values. Okay. Again, please read the discussion as well, but hopefully these two problems gives you a better idea of how we apply energy conservation. Energy conservation is important for the exam coming up on Wednesday. Now we are looking in more details in terms of potential energies, but in terms of the exam, you can keep those potential energies in the work term because chapter 7 is more the emphasis is more on the work, not the potential energy. Okay, so yeah, I'm gonna assign more problems just for practice, and then you are going to work on them, and on Monday I'm gonna answer any questions, and I will share my videos with you that when I solve the problems. Okay, so have a nice weekend.